Hi guys, welcome to Sapima tutorial. In our lesson today we shall be considering sorts. Alright, and in our class today we look at basic rules of sorts. From there we get to addition of sorts, subtraction of sorts, multiplication, rationalization, reduction of sorts, conjugation of sorts, and then we consider some sordic equations. So CPU to be dishing it out in series of videos. So today we consider basic rules of sorts. Before we do that, take note that sorts are the square roots of non-perfect squares. If you have a number which is not a perfect square and you are taking the square root of that number, we call it sort. Let's take example of perfect squares. If I have 4, the square root of 4 is 2. It's a perfect square. If I have 36 now, the square root of 36 will give me 6. It's a perfect square. Consider when you have 8. 8 does not have a perfect root. Therefore, when you take the square root of numbers like this, we say that it is odd. Let's consider other examples. I have root 30. Root 30 does not have a perfect root. I have 70, which does not have a perfect root. So all the numbers that do not have perfect roots, when you take the square root of such numbers, we say that they are sorts. We will consider the basic rules around solutions with sort. Number one, let's consider multiplication. If I have sort n times sort n, this will give me the same thing as square root of m times n. Both of them will come together inside the same square root. Let's take an example. I have 3 root 3 times root 4. If I multiply the both of them, it becomes 3 times 4, which will give me square root of 12. Alright, so this is how we operate. Then sometimes you are given a compound number, let's say 35, square root of 35, and we are asked to simplify it. You can also expand. You expand into 2 different numbers, so this will become 7 times 5, which you can now separate as square root of 7 times square root of 5. We have reduced it to simplest form. So let's consider another rule, which is division. The second one, I have square root of m divided by the square root of n. Two sorts dividing each other. The solution becomes sort m over n. Both of them will come inside the same root. Let's take an example. An example here, if I have sort 35 divided by sort 7, this gives me sort 35 over 7. Both of them have entered inside the same root, just like we have here. Then you consider division. If I divide 35 by 7, I will obtain 5. So I will have the square root of 5. This is multiplication and division. Let's consider addition of sorts. If I have sort m adding to sort n, please take note that it is not equal to sort m plus n. Both of them cannot come together when you have two sorts that are not like adding themselves. Let's take an example. I have sort 5 plus sort 6. I can never bring them together, as it is not the same thing as 5 plus 6 to give me 11. This is wrong. This is wrong. The same thing happens with subtraction. Sort m subtracting sort n. This is not, it is not m minus n in the same root. But what then do we do to addition and subtraction of sort? Let me show you an example. So for addition and subtraction of sort, let's take it as number 5. To get the addition, they must have to be the same term or like terms. Sort m plus sort n. This will now give me 2 sort m. Consider variables of algebras. If you are adding x plus x, what will it give you? It will give you 2x, all right? And just adding two sorts that are not like is just like adding two different variables. M and n is just like saying x plus y. Both of them can never come together as xy. It is not done. It is not done. So sorts that are alike can add to themselves, but sorts that are not like cannot add. The same thing happens with subtraction. So let's consider an example here. Let's assume I have 4 sort 3 subtracting sort 3. Let's consider addition first. Adding the both of them. What I work with is the coefficient. I'll factor out the coefficients of the two sorts. The coefficient here is 4 and the coefficient here is 1. Remember that for every whole number or whole variable, the coefficient is constantly invincible 1. For instance, I have an x. The coefficient of x here is invincible, which is 1. So the coefficient here is also 1. Then, having factored out 4 and 1, we take 1 square root. You see what happened here now? Factoring the coefficients and taking the common root. So we add, I will have 5 root 3. So when you have 4 plus 3 plus 3, just like when you have 4x plus x, adding the both of them, you have 5x. So see these sorts as variables. The way you handle variables is the same way you handle sorts. Thank you so much for coming on board. We will end our class here today. In the next video, I'll be considering the reduction of sorts. Sometimes you are given sort 108 and you are asked to simplify it. I'll teach you basic and simple steps to simplifying matters like this. God bless you. See you in my next video. Bye. Please don't forget to share this video to your friends. Thank you.